Thermodynamics 2, General Engineering and Applied Sciences. Okay, so yung mga pag-uusapan natin, no? We have topics to be discussed, laws of thermodynamics, no, the thermodynamic processes, and the thermodynamic cycles and efficiency. So yung tatlong lang ito, no? Yung tatlong mga bagay na ito yung pag-uusapan natin, and yung may pinakamahaba talaga na part will be this one sa topic number 2 natin, which is the thermodynamic processes. Kasi iisa-isahin natin yung bawat processes ng thermodynamics. Okay, so sige, no, huwag nating patagalin. Let's have the first law of thermodynamics, no. According dito sa first law of thermodynamics, if an amount of heat flow into a system, okay, then energy must appear as an increase in internal energy of the system and or work done by the system on its surrounding. So basically, wag mo nang isipin kung ano yung definition na yon. Just remember lang, what is the first law of thermodynamics? Nakalagay talaga dito. It is just about the conservation of energy. Remember the conservation of energy, no? We have energy cannot be created nor destroyed. It is just converted to one form to the other. Now, pag sinabi mong first law of thermodynamics, it is defined by a single equation. Ito yung tinatawag natin na first law equation of thermodynamics. It is said that the heat absorbed by the system is equal to the change in the internal energy of the system plus the work done by the system. Now, para mas ma-visualize ninyo, okay? Para mas ma-visualize ninyo ng kumbaga mas klaro, no? Isipin niyo na meron tayong system, okay? And hindi na tayo lalayo kung anong system yung pag-uusapan natin. Katawan ng tao. Okay, just imagine that one. Your body already has internal energy within it, and that by that energy also, meron ding iba dyan na gagamitin mo to do some work. Okay? Imagine a system that is your body. Now, kung kakain ka, you will absorb energy. Okay, you will absorb energy. Okay? Imagine niyo ha, this is just conservation of energy. Now, nung kumain ka, you will absorb energy. Saan papunta yung energy ng mga energy yun? Okay? Some of it will be gagamitin ng katawan mo para mag-function yung katawan mo. No? Imagine mo, it is just the internal energy para gumana lahat ng internal organs mo or gumana yung katawan mo. Okay? And also, on that energy also is mapupunta dun sa paggalaw mo, which is, in effect, you can do now some work. Okay? So that is just the idea of the first law of thermodynamics, no? Energy conservation. Okay? Energy conservation. May na-absorb kang energy and some of it will be used as, di ba, pupunta sa change in internal energy and also some of it will be used to do some work. Okay, so this is the first law of thermodynamics. Okay, so we say conservation of energy lang. Okay, now as you can see, dito nga, di ba, kapag meron kang system, no, kapag meron kang system, if this system absorbs some energy, so there will be now a change in heat which is absorbed by the system and some of it will be mapupunta sa pagbabago sa internal energy and also the change in work. Okay, so the thermodynamic system consists of the system itself, surroundings niya, and obviously yung pagitan nilang dalawa, no, the boundaries. Okay, so ngayon, let's talk about enthalpy versus entropy. Okay, ano ba yung pagkakaiba, no, ng enthalpy at saka entropy? Napakahirap na kumbaga term lang kapag babasahin mo, it is because hindi sila common, no? Kapag wala ka sa thermodynamics, no, hindi mo talaga maririnig yung word na enthalpy at saka entropy. Now, what is enthalpy? No, enthalpy, it is the kumbaga it presents the total useful energy. So pag sinabing enthalpy, ito yung keyword natin. The total useful energy. Okay? Yung mga energy na nagagamit. Okay? It is categorized into two parts. Okay? Useful energies consist of two parts. We have internal energy and the flow energy known as the flow work. So basically, enthalpy is, again, useful energy. Bear that in mind, no? Enthalpy is the useful energy. It is consists of the internal, okay, internal energy and the work. Now, very important, itong dalawang formula, this is the enthalpy equation right here, and this one right here is the change in enthalpy. Now, tandaan ninyo, change in enthalpy will be using the CP, okay? That is just, by the way guys, kung mapapansin nyo, this is just MC delta T, di ba? Kung mapapansin nyo, MC delta T lang po yan. But very specific that if you have change in enthalpy, gagamit ka ng specific capacity at constant pressure. Okay? Now guys, let me say this. Kahit na anong processes ng thermodynamics, okay, take note of that. Kahit na anong processes ng thermodynamics, the change in enthalpy will always use the CP. Okay? Will always use the CP kahit na anong klaseng process ng thermodynamics pa yan. Okay? Now, we call this one, no? CP is equal to CV plus R, and we have, by the way guys, remember this is adiabatic index. Now, may mga libro guys, may mga libro na kapag adiabatic index, hindi ganitong symbol yung ginagamit, but instead ginagamit is the letter K. Okay, parehas lang po yung dalawa, no? Yung adiabatic index, ito yung symbol, at saka we have this letter K. So most of the time kasi pag may nakita ka problem solving, normally hindi ka makakita ng adiabatic index on that symbol, but instead it will be given as the K. Okay, so guys, remember lang. Kung wala ka nito, no? Remember kung wala ka nitong dalawang ito, mahihirapan ka talaga sa thermodynamic processes. Okay, I can assure you that one. Remember this one. And ito again, sinabi ko na, pinanla ko na before sa thermodynamics 1, no, na-discuss na natin ito, naibigay ko na para at least ngayong araw, medyo sanay na tayong makita sila. Okay, so ito yung magiging isa sa mga puhunan natin ngayong araw. Okay, now, we have entropy. Now, remember nyo kanina that I've said, enthalpy was the useful energy. Okay? Enthalpy is the total of the useful energy na pwedeng magamit ng system mo. Now, on the other hand, pag sinabi mo namang entropy, okay, entropy is the absolute kumbaga, measure of the energy that is no longer available. Okay? No longer available to perform useful work. So, pag sinabing enthalpy, basically useful. Kapag sinabing entropy, basically useless energy. Diba? So, ayun yung magpagkakaiba nila. Enthalpy, useful energy. Entropy, hindi mo na nagagamit. Okay? No longer available to perform useful work. Okay? And other definition of this entropy is that is the measure of randomness or disorder of the system. Now, kung titingnan mo, ay anong ganito? May makina ka, di ba? May makina. For example, may makina ka. Sasakyan, no? May makina ka sa sasakyan. So, lalagyan mo yan ng gasolina, eventually that will be the energy and it will be converted to other forms of energy para gumana ngayon yung makina mo. Now, take a look at this. Now, imagine this one. Wala pong, kumbaga, engine na 100% efficient. Okay? Like, hindi lahat ng energy from the gasolina will become useful energy. Okay? Some of it will be useless. Now, unang-una, okay, yung pag-init pa lang ng makina. Okay? Kung kaya mong gumawa ng makina na hindi umiinit, then that would be a very, very, very good, kumbaga, machine. But dito, klarong-klaro, no, na hindi po pwedeng mangyari na magkaroon ng 100% efficiency. So there will be that entropy, no, energy that will be, kumbaga, not available, no, to do useful work. Okay? And as you can see, it is the measure of randomness or disorder of the system, which makes your machine paluma habang ginagamit mo siya through time. Okay? So basically, this is what we call entropy. Okay? Now, the change in the entropy has, again, dalawang formula. Okay? So we have this one right here, Q over T, the heat. Okay, ito Q. Ayan, it would be sensible. Okay, it would be sensible, or we can have that one as the latent heat. Now, basta Q, heat yan. And over the temperature, guys, this should be in Kelvin. Okay? Now, another formula is this is equal. Okay, depende sa given. No? This could be equal also into this. No? MC ln of T2 over T1. Now, unang-una na dapat mong makita dito. Okay? Dapat mong makita. I am giving you already the pointers. Ha? Remember guys, ang dami pong formula dito at kailangan nating malaman ano yung gagawin dapat. Okay? Now, kung mapapansin ninyo, this is MC. It is not specified whether it is MCV or MCP. Okay? Ngayon, ang entropy guys is nakadepende kung ano yung process niya na nag-undergo. Okay? Anong process nag-undergo yung iyong system. Okay? So mamaya, mapapansin ninyo, magbabago po itong CP. Okay? Just as early as now, dapat alam na natin yon. Yung C na to, okay, magbabago po ito. Depende sa process na nag-undergo yung ating system. Okay, so basically we've now defined, no? Again, we have the enthalpy, and remember, enthalpy will always be using CP, okay, the MCP delta T. And kapag sinabi mong entropy, ayan, ito naman is depende ngayon yung C, whether kung anong process meron siya. Okay? Now, that's the difference when, again, with the entropy and enthalpy. Enthalpy is the useful energy. Entropy is the useless energy, basically. Okay? So, ngayon, we have internal energy naman. Okay? So tatlong bagay na yung napag-uusapan natin which is ito po yung kadalasan na tinatatanong sa board exam. The enthalpy, the entropy, and the internal energy. Now, internal energy is of a thermodynamic system is by definition the sum of the mechanical energy of all the molecules or entities in the system, or it is stored energy within the body. Napakadaling maintindihan na bakit siyang tinawag na internal. It is because this is the energy within the system. Okay? Within the body of the substance by virtue of the activity of molecules or vibration of atoms within the molecules. So basically, internal within the body or a substance. Okay, ngayon, kung mapapansin ninyo, magkamukha lang parehas almost, no? Yung ating formula ng internal energy at saka ng ating enthalpy. Okay? Now, to make a comparison, isulat ko natin dito. Enthalpy was mCp delta T or change in temperature. Okay? Ngayon, kung mapapansin ninyo, internal energy is gumagamit ng Cb. Okay? So this is why what I did in the thermodynamics 1 was expose you guys what's the difference between the specific heat at constant pressure, what's the specific heat at constant volume, how to convert one to other. Okay? Kumbaga specific heat. Meron tayong dalawang formula kanina. And the relationship na ratio which is the adiabatic index. Ngayon, ito din tandaan ninyo. Kahit na anong process ng thermodynamics, okay? Kahit na anong process ng thermodynamics, etong dalawa, hindi pong nagbabago yan. Okay? Hindi pong nagbabago yan. So basically, what will be changing all the time is the formula of change in entropy, okay? The formula within the change in entropy and the heat absorbed. But not the change in enthalpy, okay? Not the change in enthalpy and the change in internal energy. Hindi po nagbabago itong dalawa kung kahit na anong process ng thermodynamics maidi-discuss natin mamaya. Kaya makikita niyo hindi po magbabago 'yan. So enthalpy will always be using Cp and change in internal energy will always be using Cv. Okay? Now, work done by the system, no? Kung meron tayong dalawa dito. By the way, ano yung work done? Klarong-klaro kasi by definition itself, the work, no? Work is a force created by any source can do the work by moving an object through a displacement. So ibig sabihin, kung may paggalaw, it means there will be that force, no? There will be that force na tawag dito na kumbaga nagamit para kumbaga igalaw yung isang object, and there will be a change in kumbaga in position, or should we say displacement. That means there is that work. So what is happening in a work done kapag meron tayo sa thermodynamics? May dalawa. Okay? Una is a non-flow work. A non-flow work means wala pong pagbabago, no, sa kumbaga sa tawag dito sa mass ng kumbaga ating object. Walang nakakapasok. Should we say this is a closed system. Okay? So by the way guys, take note of this also, no? Work done by the system is a positive work. Work done on the system is a negative work. So basically, parang magkaiba siya, no? Magkaiba siya sa kapag ang perspective mo is tao. Naisipin nyo, if you are a human being and you do some work, that is a negative work. Why? You've spent energy, right? Okay, just as depende sa perspective, no? Tao ka, gumagalaw ka, you've done some work, you've spent energy. It's a negative, di ba? It's a negative work. Tapos kapag naka-absorb ka naman ng energy, it's a positive work. Why? Tao ka, di ba? But if you are going to take a look at a thermodynamic system, a system is designed, or let's say, para mas madali, a machine, okay? A machine is designed para magbigay sa'yo ng trabaho. Okay? That is why work done by the system is a positive. Kasi yun yung trabaho niya, magbigay ng work. But if yung system mo ngayon, yung nag-a-absorb ng energy, And ibig sabihin, that is a negative work. Okay? So it depends on the perspective. Okay? So dito, ang perspective natin, machine, system. So kapag nag-absorb siya, negative work po 'yon. Okay? So by the way, ito yung nangyayari sa non-flow work, no? Because there is pressure, no? Imagine niyo, itong ating object, itong object na ito, okay, itutulak ng pressure pataas. And remember, pressure is a force per area. So there will be that force. Okay? And eventually, nung tinulak niya papunta dito, okay, nandito na yung object natin, okay, there will be now a change in volume. Okay? The change in volume. So because of this pressure, there is now a change in the volume or the space being occupied by the gas. If this is a gas, then there will be now a work done. It is because there is a force because of the pressure and there is now a displacement. So work non-flow is we have P change in V. Okay, so we have P times V2 minus V1. Now, that is just generally. Okay? Meron din tayong tinatawag, no, na flow work. Okay? Flow work is the work done in pushing a fluid across the boundary of the system. So basically, this is happening if you have an open system. Okay? There is a kumbaga happening if you have an open system. So sabi nga dito, no, when there is a fluid that can cross the boundary of the system going into or going out of the system. Okay? So, ngayon, if yung system mo, okay, if yung system mo already, no, already has the kumbaga, the initial pressure and the initial volume, and what happens is nagkaroon ng panibago, no, panibagong fluid na pumasok, that is why it's a flow work. Okay? There will be now a secondary pressure, okay, at saka panibagong volume niya. And what happens is, para makuha yung work done or the flow of that or the flow work, then you have to get the difference, no? P2 V2 minus P1 V1. Now, okay, I just want you to realize this, okay? Pag nakita mo itong PV, pag yung mga PV sa thermodynamic ngayong araw na pag-uusapan natin, pag nakita mo yung PV na yan, okay, yung P pressure times volume, ibig sabihin, this formula is not just P2V2 minus P1 V1. Okay, bakit? It could change depende sa given na nasasang-ayon. Bakit? It is because remember, PV is equal to nRT. Di ba? Also, PV is equal to mRT. And also, PV depende if you have nKT. So it means that this formula is initial lang. Okay, initial lang. So it could change depende sa given. What if ang binigay sa iyo the number of moles and the temperature? So still you can get the work done. Okay, you can still get the work done. It is because PV, kung binigyan ka ng number of moles at saka number of the temperature before and after, then you can still get the difference because PV is equal naman din dito. Depende, mass ba or the number of molecules. Okay? So pag nandyan yung PV guys, normally, kumbaga, hindi siya direct substitution. Sometimes you need to derive it to a proper, kumbaga, equation na nasasang-ayon sa given mo. Okay?